Preparation of amines. Amines can be prepared by reduction of nitrile compound. Aromatic amines can be prepared by reduction of nitrile compounds using zinc in the presence of H+, or SnCl2 in the presence of H+, or Fe in the presence of H+, means in acidic medium. So nitrobenzene, the reactant for reduction of nitrile compound, we use nitrobenzene, all nitrobenzene, and then zinc acidified, SnCl2 acidified, Fe acidified. It will produce aniline. Reactant nitrobenzene, it will produce aniline. Next, it can be prepared by reduction of nitrile. Amine can be prepared by reduction of nitrile. Nitriles are reduced to primary amines by hydrogen in the presence of catalysts such as NiPT/Pd, nickel, platinum, or palladium. And then reducing agent LiAlH4 followed by hydrolysis H+, H2OH+, and then NABH4 in methanol. This one 1 LiAlH4, 2 H3O+. Reduction of nitrile. We use nitrile compound, the CN, C triple bond N. The CN means C triple bond N attached to any R group, and the nitrile compound undergoes reduction reaction. Nitrile undergoes reduction reaction, can produce amine. When you use H2 or LiAlH4 or NABH4, the carbon, if it undergoes reduction, the carbon will receive 2 hydrogen and will receive 2 hydrogen. That is reduction of nitrile. We know that reduction is accepting hydrogen. So this becomes CH2 NH2 after reduction. CH2 NH2. Here CH2 NH2. Next, it can also be prepared, amine can also be prepared by reduction of amide. Reduction of amide using LiAlH4 followed by water can yield a primary, secondary, or tertiary depending on the type of amide used. It depends. For example, here amide C double bond O attached to R group. C double bond O has NH2, so this is what we call amide. C double bond O that has NH2. It undergoes the reduction reaction LiAlH4 H2O in amide, LiAlH4 H2O, and the carbon double bond O will receive 2 hydrogen. It will receive 2 hydrogen. It becomes CH2. NH2 remain unchanged. Here CO becomes CH2, and the side product water. This O attached to another 2 hydrogen. So here C double bond O that has NH. This C double bond O will become CH2. This one CH2 plus side product water. This is reduction of amides to form the amine. Primary, secondary, or tertiary, depends on the compound or the pattern of the amide. Next, amine can be prepared by Hoffmans degradation of amide. Again, we use reactant amide. This is reduction amide. This one, Hoffmans degradation of amide. We warm the primary amide with bromine in sodium hydroxide. Primary amide here, warm with bromine in sodium hydroxide solution, means bromine and sodium hydroxide water. Sodium hydroxide solution, sodium hydroxide water, or any basic water with the presence of bromine, and we warm it. This reaction is used to synthesize the primary alkyl amines and aryl amines. The elimination of carbonyl group is shortening the length of carbon chain by 1 carbon atom. So this is the reason why the name is degradation. We remove 1 carbon atom. Degradation, remove. So for example, here we have C double bond O and H2 undergoes Hoffman degradation amide, the NH2 means you remove the C double bond O, remove, and then this NH2 will attach to R, amine. The C double bond O will become CO3 2 minus. This is the side product of Hoffman's degradation of amides. Example here, C double bond O, NH2, this is amide. Hoffman degradation, you use bromine, warm this amide, and bromine, basic, water. So remove C double bond O, this is R. Remove C double bond O, R, this R will attach to NH2. So R attached to NH2, side product CO3 2 minus. So we can reduce one carbon if we use Hoffman's degradation of amides. Grignard reagent, we can increase carbon. Hoffman's degradation, we can decrease carbon, remove carbon by 1. Side product CO32, so 1 carbon only, so you can decrease by 1. More example, hexanamide, C double bond O NH2, in Cl2OH minus H2O, remove the C double bond O, this is R group, so the R will attach to N, like this. Side product CO232 minus. This is C double bond O, NH2. Hoffman degradation of amide, use bromine. Basic, water, remove the C double bond O. The R group, this carbon that attached to C double bond O, that carbon will be bonded to the nitrogen, like this.